9.3 separable equations. We have looked at first order differential equations from a geometric point of view, direction fields, and from a numerical point of view, Euler's method. What about the symbolic point of view? It would be nice to have an explicit formula for a solution of a differential equation. Unfortunately, that is not always possible. But in this section, we examine a certain type of differential equation that can be solved explicitly. A separable equation is a first-order differential equation in which the expression for the derivative of y with respect to x can be factored as a function of x times a function of y. In other words, it can be written in the form the derivative of y with respect to x equals g of x times f of y. The name separable comes from the fact that the expression on the right side can be separated into a function of x and a function of y. Equivalently, if f of y does not equal 0, we could write equation 1, the derivative of y with respect to x equals g of x over h of y, where h of y equals 1 over f of y. To solve this equation, we rewrite it in the differential form. H of y dy equals g of x dx, so that all y's are on one side of the equation and all x's are on the other side. Then we integrate both sides of the equation. Equation 2. The integral of h of y dy equals the integral of g of x dx. Equation 2 defines y implicitly as a function of x. In some cases, we may be able to solve for y in terms of x. We use the chain rule to justify this procedure. If h and g satisfy 2, then the derivative to d over dx of open the integral of h of y dy restarting that the derivative d over dx of open the integral of h of y dy close equals d over dx of open the integral of g of x dx close. So d over dy of open the integral of h of y dy close times dy over dx equals g of x. And h of y times dy over dx equals g of x. Thus equation 1 is satisfied. Sidebar. The technique for solving separable differential equations was first used by James Bernoulli in 1690 in solving a problem about pendulums, and by Leibniz in a letter to Huygens in 1691. John Bernoulli explained the general method in a paper published in 1694.